Hi folks, today's episode in the Microcontrollers series tutorial thing in the BIVBlog. I want to talk about how to get all these sorts of things we've taken care of individually so far, like compilers, software programmers, hardware and programs and so on, orchestrated. And because we're using Unix, we're not going to use an IDE, which other people do, we leave that to them, but instead we're going to use a tool that's been around for as long as I can remember called Make, which a lot of people for some reason are really scared of. No reason. It has a couple oddities, but it's something you can come to grips with. And once we've taken care of that, dealing with this thing is as easy as 4 or 5 keystrokes. And in case you wonder, yes, 4 weeks ago by now, I've been to the ITF meeting in Berlin. I mean, if it's basically next door, you might as well go there. So I've got the t-shirt, I've got the badge, and what's most important, I've even got the fan. Yes, it was in the middle of summer, and apparently the organizers were afraid that all the people plus the assorted machinery they show up with might actually kill the air conditioning. Anyways, let's get rid of this. Today I want to talk about Makefiles, and Make has a long history and quite a reputation. Nothing to worry about this. If you're familiar with Makefiles, by the way, just go to the forum at www.stepladder-it.com/bivblog/41, grab the Makefile there. It should work with all the files we've used in the previous episode, and you should be pretty much happy. Give it a quick glance, call it a day, and there's nothing much interesting I'm going to tell you. However, Make has a reputation, and I remember when I was a graduate student, there was this thing people were saying, with Make there's basically one way to do it: grab a Makefile from somewhere, try to tweak it until it does what you kind of need, and then live with it, which was stupid, but that's what a lot of people told us. And if you know a couple things about Make, it's not really that scary, and it can make your life tremendously easier, especially once programs or projects grow beyond the trivial stage that we are currently in. And even now, it actually makes sense. We have 3 different, have them here, sitting here again. We've got 3 different programmers connected to 3 different target boards, and I might actually want to install all of them at the same time. And not forget whatever compiler option I might actually need. So I'm going to use them. And once we're through with that, we get to the more interesting stuff. Next episode or so. And yeah, why are people so afraid of Make? Make is strange. It's different than a normal programming language because it doesn't do things in the order they appear in the file. It doesn't necessarily do things in any specific order at all, depending on how you use it. And it's really good at only doing the stuff that's needed, but doing it in such an order that things actually work. And to a lot of people that seems like magic, but the only trick really is you tell it, this is the file you want to build, this is the files that it builds it from, and make sure that whenever one of the source files is newer than the target file, rebuild it. That's pretty much the entire core idea behind Make. And then given suitable options and a suitable kind of Make, it does things in parallel if you want, makes the console output kind of garbled, but a lot of times it just makes sense on today's multi-core machines, including Raspberry Pi version 2 and up. So, well, we should just get used to it, make use of it. It's not really that difficult once you know the basics. There are a couple things you have to know about Make. There are a couple conventions you have to know or should stick to, and of course there's this arcane feature you find in at least some programming languages called comments, and yes, they're a good thing and Make supports them, so use them. Because Makefiles, there are basically 2 kinds of Makefiles. They're the ones that are in continuous state of flux because they get updated all the time, and there are those that nobody wants to touch anymore, and they're just used as they are, and hopefully they continue to work. Don't go with the second one. Just make sure that your make files are easy to understand, easy to come to grips with, and people will maintain them and adapt them along with the rest of your project as they work along. That's one problem. Other problem is there is a prehistoric version of Make that I've actually started with a long time ago, and from there multiple rather divergent variants have evolved. The two most predominant these days are GNU Make, which is what we're going to use because all the Linux people are using it, and I'm still using the Raspberry Pi running Raspbian as my high-end development workstation thing. And there's the BSD Make, sometimes called PMake. PMake because it was the first Make that actually did things in parallel. And with the more advanced features, their syntax varies quite drastically, up to the point that there are actually tools that create make files from whatever sort of input. We're not going to get into these. Doesn't make much sense at this point, and I'd have to read up on these as well because I generally try to avoid them. But for what we're going to do, we're just going to use make, and basically by entering make, we save a lot of time over running over the screen of an IDE and trying to remember to click things in the right order to make things happen the way we need them. Okay, so much about that. Let's give it a look. So we have our 3 target boards sitting here again, and they're doing a rather boring single blink routine. I hope you can still kind of see that. Lighting is a bit of a problem here. That might actually make things slightly better. Yeah, okay. So they blink once. I have a directory with our 3 C files from the previous episode, plus a Makefile, which I have open here in Emacs, which doesn't have anything but comments, starting with a hash sign, going to the end of the line, containing the command line invocations we've used in the previous episodes. Now, what we need to do, this file has to be called Makefile, and nothing else. Or you use make -f non-standard standard Makefile, whatever. You can do that if you really want to, but don't. And let's start with the compiler invocations. So these 3 lines. And what we do, or can do, is tell make how to build blink-arduino.elf from blink-arduino.c. It goes like this. We say blink-arduino.elf depends on blink-arduino.c, which already tells make that whenever the C file gets updated, we also need to rebuild the ELF file. And yes, by the way, turning back your computer's clock and using make is a bad combination. Don't do that at home, and especially not at work. And this basically tells make how to build that the ELF file depends on the C file. If we now say make blink-arduino.elf, we have an error, no rule to make target whatsoever, because we still need to tell make how to do this. And this is what you put in the next line beneath, and this line has to start with a tab, and this has to be a tab, not 8 spaces. That's something different, and you'll get some more or less arcane or obscure error messages depending on the kind of make you use if you do that. And with that, yes, we can build our ELF file, and yes, here it is. Well, that wasn't too difficult, so we might as well repeat that with the others. Blink launchpad.elf depends on blink launchpad.c, and blink debug express.hex depends on blink debug express.c. Now, what we have at this point is we have a file that contains all the compiler options we need for all and everything. So that's already kind of convenient. We just say make blink debug express.hex. If we save the Makefile first, of course. And there it is. And if you think, okay, error might have occurred, you say some echo $, which gives the exit code of the last command you run, and make returns a 0 if everything works out fine. Good. Now, the interesting thing is, if we invoke this again, make will notice that blink debug express.head is up to date. If now we touch blink debug express.c, because we've changed it, at least as far as the timestamp goes, make will rebuild the file. That's what make is good for. And yes, in large projects, this can save a hell of a lot of time. Now, next rules we need are targets to install stuff, and we call these install-arduino. And that depends on blink arduino.elf. And this is the command we do. Now, if we just put it like this, we'd actually have a bit of a problem, because make would expect make install Arduino to actually build a file called install Arduino. And we don't do that. We don't build a file here, we just do something. And we have to tell make about that, and that's done with starting first column, the phony uppercase install Arduino, save, run it. And once we do that, we should actually see the Arduino do a different blinking pattern. Like, I think it's 7 times in a row. Yeah, that looks better. That looks like it did what it should do. Let's try again. Okay, that should actually work. Let's give them a try. That looks good. And here's the picket, and that shouldn't work because there's no programmer connected here. Let's fix that. And there's the programmer connected. And yeah, that looks better. And if we disconnect the program again, we actually see the new blink pattern. That's pretty much the core idea behind make. Order things that need to be, find out what needs to be done because things have changed. You've edited some files. Rebuild whatever files are created from them in the correct order, and avoid recompiling pretty much all and everything all the time. Yes, for simple projects, you could just do the compiler and whatever invocations in a shell file. But once projects get bigger, that's getting pretty much prohibitively slow. So that's where make is really, really useful. That's the start. Next is to define targets that let us do things more conveniently, because they kind of aggregate certain jobs. And normally if you invoke make without, oh, hang on, this is a good one. The order in which rules appear in a Makefile doesn't matter at all, with one exception. If you invoke make without any command line arguments or without specifying a target to build, it'll take the first one it'll find in the Makefile. And that's what you should keep in mind. And the first target you should actually have is a phony target. It's commonly called either build or default. I personally stick with default, but whatever you and the crowd you're with prefers. And that does pretty much all the kind of building. Sometimes you have an additional phony target all, which builds some extra stuff you don't generally need for basic testing, like updated documentation using Doxygen or whatever. But okay, that might actually be a target called doc, and then make all would do default plus doc plus whatever. Might have a target called test if you have some kind of regression tests, if you're into this sort of stuff, which is a good thing. And then you have a target, normally a separate target called install. Install does basically everything to actually get things out into the wild. With normal projects, it installs projects in, user bin, user local bin, or whatever. And with microcontrollers, it just installs things on the microcontroller boards, as far as I'm going. So let's give it a look and fix it up. First thing, we make this kind of a section. This is just a convention, but call this target rules. Rules to build these various targets. Targets are the destination files basically, and the rules are how to build them. We have standard phony targets, and the first one should be default, and we could actually have target install, and yes, you can specify these like this, and default depends on blink arduino.elf, blink launchpad.elf, and blink bugexpress.hex. And install depends on there, that looks good. Let's clean this up a little bit. Looks nicer like this. And the reason why this has to go on top is because the first target defined, default, is what happens if you say make. And again, I should probably save the Makefile first. Nothing to be done to default. And then a target you pretty much always want to have is called clean. Clean doesn't have any dependencies, but it does something like an rm-f, anything with a tilde at the end, because those are backup files from Emacs, anything elf, anything hex, anything o, anything lst, anything .cod, anything we're missing. There is an ASM file. That's nice. And now we can say, and we can test the Makefile again, make, and we see it runs the AVR, MSP430, and STCC compiler all in one go. That's nice. And what we can also do is make install. What's that? Install arduino.elf. That shouldn't be elf, of course. And there we go. And yes, we should reconnect the Picket programmer here again. Okay, let's try again. And what you notice is, because these aren't files we built, we don't have timestamps, and with that we rerun everything all the time. And now let's do a time, see how long it takes. Okay, 7 seconds, not too bad. But if we say make minus J, for whatever reason this is called J, it means run in parallel, run 3 things in parallel, give it a run. The output gets a bit garbled because we have 3 different programs producing output all the time, but we effectively half the time it takes make to run. That basically means that one of these is much slower than the others. And that's something you pretty much always want to have with Makefiles. So we've got dependency sorted out. We can run things in parallel, which is nice, and we have the compiler options configured in a file, so we don't have to type them all the time, or hope we still have them in the command line history. However, that's only the very beginning. Next thing to do is put another section on top, which contains things that might appear in multiple places, and put anything that normally needs configuration there, so you don't have to worry about the rest anymore. Here's what that looks like. By convention, configurables or Makefile options are named using uppercase. You'll frequently see things like C flags, which is basically something you pass to C compiler in pretty much all cases. You see that pretty often, but it doesn't make much sense at this point. So what we say here is avr C flag. Let's do this really nicely. We say C flags is nothing. We say GCC C flags is C flags, and then we go for the nice stuff here, which we use with GCC only. I mean, we need to replace that later on. And then we say avr C flags is GCC C flags, and we say MSB C flags is GCC C flags, because we're using GCC in both cases, and we say pick C flags is use non-free. And yes, we could have some SDCC C flags first and then make pick C flags include that, but that's gonna get overkill, and that would make things less easy to come to grips with. But what we should actually have here is something like C flags in here as well. Sorry, I forgot about that. Okay, and with that we can already do things to clean up. We make this avr C flags, and yes, you need to put parentheses or curly braces around variable names which are longer than one character. That's another mistake people frequently do. If I did it like this, it would assume a variable called $A and VR flags going literally behind it. And yes, sometimes you see curly braces which have slightly different syntax. Doesn't really matter at this point. Do the same for MSP 430. And for the pick. Now at this point you might ask, what's the advantage of putting things on top here? Well, you see, by length of it, the way we do this, normally you only have to worry about the top of a Makefile. That should contain pretty much everything you need to mess around with if you need to change things a lot of times. And that's what makes Makefiles reasonably easy to maintain. Now, that isn't all, because we also have to say things like what MCU type, and we actually have this 80 mega 32.8p appear in two places. We should actually put that in quotation marks so the syntax highlighting works correctly. It gets confused by the colon here. Okay, that's where things get actually interesting. Now we say Arduino MCU is 80 mega 32.8p, and yes, there's a reason why I call this Arduino, and we can replace that here And with that, we actually made sure that if we switch to a different microcontroller, we don't have to replace it all over the Makefile. And once this gets more complicated, that can actually be a bit of a pain. It just goes in one place. And we say launch pad MCU is a what is it? MSP 430 G2553. And similar, we say debug express MCU equals 16F887. And yes, there's a reason why I don't put the pick in front. But before we talk about that any further, clean things up. If you make sure that these indentations here are consistent, it makes things much easier to read in the long run. And we also need to debug express MCU family, which is a pick 14. Now we can fix these things as well. So here goes Launchpad MCU, and here goes debug express MCU, and here goes, that should actually be, what do you have there? Hang on. That's one of these things to screw things up. Yeah. Basically we say -P and then it's debug express MCU. P is part of the option. So, and here we say debug express MCU family. Another thing, you can actually do line continuations like this. Just put a backslash at the end and continue on the next line. That's fine. And here we have pick debug. Okay, let's see if it still works. Make clean, make install. That looks good. And if you want to be really sure, echo $? Shows you the exit code of the last program on the shell, and if it's 0 means no error. So things are getting better. One more thing you want to make configurable is with the programmers, and basically you say Arduino prog type is, the Arduino programmer type is an STK 500 version 2. And make that prog def, and also go for line continuation here. And similarly, it's launchpad prog type is an RF 2500, and that should actually be it. Yeah. Launchpad prog type. We don't need to specify a device here, and with the pk2 command we don't even have to tell it that it's using a pk2 because pk2 command doesn't support anything else. So that looks good. The only thing you might actually want to play around with is the ordering in this file. I personally like this kind of ordering because it says about compiler things first. It then says about the particular targets we're using and where they are connected. I might actually do something like this. Okay, and again, comments are not forbidden. And if you look at these things, yes, that looks, well, still kind of intelligible. One more thing I don't like is that we have so many separate phony lines here. That's unnecessary. Sometimes empty lines make things easier to understand, but sometimes they just bloat things. That's pretty much what you do with Makefiles all the time and everywhere, and it doesn't really matter what kind of make you use, except for the make-j option to run things in parallel. And this is the basic outline of a Makefile. You start off with configurables. You then have some phony targets to provide some kind of abstraction, so you can build all and everything you need with one go without having to specify anything and without having to reorder the subsequent main target section such that the most important thing is on top or whatever. That's nice, but that's really still just the beginning. Only with what follows next, it depends on what kind of make you use, on how the syntax works. I'm just going to show you the GNU make stuff, which is not necessarily my favorite, but it gets the job done, so I'm not going to complain. And the idea is that if we had different programs to build, for example, we have blink and don't blink, and blink slowly and blink fast, whatever, then we'd have to fix things and have targets for every single file, for every single platform. And that can get annoying. There is a trick to this, which we're not going to need right now, but which is actually kind of useful. And these are called target patterns in GNU Make. The BSD world uses for loops to re-evaluate some specifications or rules for different whatever strings, but GNU Make doesn't offer that feature, at least not the way we'd use it on BSD Make, so we just stick with the GNU way, and let me just show you how. Now, as you see, all the stuff we're using here is called blink-whatever. So we could actually say something like main program prefix, so main equals blink. And then we can do something like blink with main. And that is already quite nice. Except that, of course, it screwed up the indentation here again. And but we can do better than this. Now, this is going to get a bit more complicated. We can basically say if you have a target of the pattern whatever -arduino.elf, build it from whatever -arduino.c, and this is GNU specific. Of course, this doesn't work because it's still built blink arduino.elf with the command line here, and no, to my knowledge, this doesn't work. Let's actually give it a try. And here you see avr-gcc says no such file, so you can't use the percent sign here in the target rule. But what you can do is $@, that's the output file, this one here with the percent sign expanded, and here you say dollar less than. And basically the same thing here. And here it doesn't actually work because, let me show you again. This works, but here we must not have the trailing .hex. It's a peculiarity with STCC, and to take care of that we say $@ and then we say substitute .hex with whatever. Kind of strange, but okay, this should actually work. If we run this, make clean, make install, okay, make clean, make install. Okay, what is it doing here? avr-gcc. Something went wrong here. Let's try again. Yep. That looks good. And this point you might ask, okay, why not use % whatever here? But there's a problem. We can use these to build pretty much arbitrary programs and use these to install, but here we actually have to specify which file to use. There is no link or whatever in the target specification, so we can't use a % sign here in the dependency. So yeah, that's, as far as I'm concerned, pretty much all I want at this point. You can actually have main split here into multiple targets if you want to build multiple programs, and you could actually say something like make install main equals bonk, which would try to build blonk whatever for the targets and then install that, which we don't have anything here. But for the time being, I'm reasonably happy with this. And the last thing you should actually do is check if there are any kind of inconsistencies or whatever. At least for now, I'd say that's good enough. And for the next episode, that should do, for the next couple episodes actually, we will use this Makefile as a basis to work things, to elaborate things, to make things more complicated, and hopefully at some point more simple again. But this is really what you do with the Makefile. So what, and summarize this, have we seen? First, it's nothing to be scared of. Second, don't forget a tab is something else than 8 blanks at the beginning of a line. Third, don't overdo it. Just keep things simple. Fourth, have these 3 different sections. First, the configurables, which is where you always muck around with in the long run, or which you adapt to your own needs. Second is the various default targets you want to use, and third is the target or pattern targets for whatever you want to build. And last, of course, is don't let people scare you off with this. Just write them like this. Don't go over the top, and Make is really, really going to be helpful. And yes, I've said that in the beginning as well. Okay, so much about that, and I think we are through with this picture and the problems around this, and we're just about to get to the fun part. Well, the next episode, I'd say. And at this point, I'll actually go with this one picture once more. We've taken care of all this stuff: compilers, programmer software, programmer hardware. And what we can do at this point is we can either muck around with the target boards, or we can deal with the source code. Actually take a look at the source code we've used so far. But there's something I've learned from reading a couple web blogs, web pages, whatever, when it comes to microcontrollers, which I found quite surprising. First one is, there are a lot of people on a very limited budget, or at least they say they're on a very limited budget, who soldering iron is way too expensive. That's so much money and that sort of stuff, which I don't quite follow. But okay, I'll try to cater for that best I can. And yes, I know all these small sums actually sum up in the long run. And the other thing is that I found really strange is that apparently a lot of people are mortally afraid of soldering. Now, that's really strange. I mean, when I started as a kid with electronics, there's some Cosmos electronics kits for playing around with. That was cool, but I always wanted to have my own soldering iron and do something properly. But apparently, a bit of an oddball there, I was back then. So what I'm going to do next time is go for breadboard. Do a couple things on breadboard, and yes, that opens a couple additional problems, but it gives us much more freedom when it comes to the target boards. We can use different microcontrollers than we have on these development or evaluation boards, and that actually has a number of advantages. If you build an evaluation board because you're TI or Microchip or Atmel, you frequently use a fairly big microcontroller to provide people with all the features that are available in their product line. And what basically happens is you buy one of these boards, pull out the data sheet for that microcontroller and think, okay, that's about twice as long as Tolstoy's War and Peace and the Bible together, and that scares you off. If we go breadboard, we can, spend €1 for the smallest possible Atmel microcontroller, for example, 170 pages instead of 800 watt of documentation, and start with that. It's much less daunting. And if you actually fry a €1 microcontroller, not a €15 one. So that's about saving money again. It actually makes things easier to go with the small ones first. So plan for me at this point is get whatever we have onto breadboard, make sure everything works. There are a couple things to learn there as well. And then move to some smaller, preferably microcontrollers, at least in some cases. And then we take a look at the sources. If you watch this, you already have these boards or want to use them because you can't be bothered with breadboard or even possibly soldering things up properly. Nobody forces you to watch these episodes in a specific order. I have to record them in some sort of order because I don't know a way to do this in parallel with myself. But this is really up to you and what you're interested in. Anyway, that's the plan for the next episodes. For these, I hope you enjoyed this. If you want to get hold of the Makefile, I just put in, there's one thing more missing actually, copyright notice in front, so basically you know who to blame if things don't work out the way you want. I put that on the forum at www.stepladder-it.com/BIVBlog/41, and you just find a lonely Makefile there, I guess. And if you have questions, comments, suggestions, don't like the Makefile at all, want to rewrite it for BSD Make, by all means, come to the forum, leave your stuff there, or tell me where to link to. Everything fine with me. And other than that, well, I'll be on the road again for a couple days from tomorrow on, but Still, hopefully, see you again soon. Bye.